Hello there, so this is our example of our VT graph. So you will see here that at point A, from 0 to 3 seconds, you have a positive acceleration. From A to B, you have a negative acceleration. From 6 to 8, from B to C, you have a negative acceleration. From D to E, you have a positive slope. And from E to F, we have a negative slope. Okay, so in this problem, we will find letter A, find the acceleration from 0 to 3 seconds. Okay, so you will see here that the acceleration is positive. Okay, so you will find for the slope, okay, from 0 to 3 seconds. And for letter B, find the acceleration from 6 to 8. For letter C, find the acceleration from 3 to 6. Letter D, find the total distance from 3 to 8. And for letter E, find the total displacement from 3 to 8 seconds. Okay, so for letter D and letter E, we will distinguish between distance and displacement. Okay, so finding for letter A, find acceleration. Our letter A is simply V sub 2 minus V sub 1 divided by T sub 2 minus T sub 1. So what is our V sub 2? It's 15 meters per second minus V sub 1 is 0 divided by T sub 2 is 3 minus 0. Okay? So we will have 15 divided by 3, so the answer is 5 meters per second squared. Okay, so it is positive. Okay, so for letter B, you will have to find the acceleration from 6 to 8. So you will see here that we have a negative V here. Okay, so this is a negative here, and of course we will see what we will get as an acceleration. Okay, so applying our canon, A equals V2 minus V1 divided by T sub 2 minus T sub 1 simply equal to V2. What is our V2? It's negative 10 minus our negative 10. Our V1 is simply equal to 0, okay, divided by T sub 2. Our time is 8 seconds minus 6 seconds. So our answer will be negative 10 meters per second divided by 2 seconds. So our answer is simply equal to negative 5 meters per second squared. So you will see that we have a negative slope. Okay, then for our letter C, find the acceleration from 3 to 6. So acceleration from 3 to 6, so as I've told you, again, it gives you a negative slope. Okay, so for letter C, acceleration is V2 minus V1 divided by T sub 2 minus T sub 1. So our V2, okay, this is the initial, this is the final. V sub 2 is 0 minus V sub 1, okay, is 15 meters per second divided by the time is 6 seconds minus 3 seconds. So you will have a negative 15 divided by 3. So your answer is the negative 5 meters per second squared. Okay, so you will have a negative acceleration. Now for letter D, we need to find the total distance from 3 to 8, and the total distance is simply adding the area here and the area here. Okay, so our area is simply area 1 is simply equal to 1/2 base times height. So area 1, 1/2, the base is 6 minus 3, which is 3 seconds, minus the height, it's 15 minus 0. Okay, so it's 15 meters per second. Okay, so our area 1 is simply equal to 45 divided by 2. Okay, so the answer is 22.5 meters. So second will cancel. So our area 1 is 22.5 meters. Again, our area 2 is simply equal to 1/2 base times height. Okay, and our area 2 is simply equal to 1/2. The base here is 2. 8 minus the base, this is our base. Okay, 8 minus 6, and our height is this one. It's -10. Okay, we don't include the negative because when we talk about displacement, we don't have any direction. So we'll just put 10 minus 0. So the height is 10 meters per second. Okay, so our area 2 now is simply equal to 10 meters. Therefore, the total distance from 3 to 8 seconds is simply equal to area 1 plus area 2. Okay, which is simply equal to 32.5 meters. Okay, so for finding the letter E, finding the total displacement, okay, from 3 to 8 seconds, okay, the magnitude is the same, but the only difference is that our area 1 is positive 22.5 meters and our area 2 is simply equal to -10 meters. Why? Because this is lying along the negative y. Okay, so therefore the total displacement is simply equal to is simply equal to 22.5 meters minus 10 meters. Therefore, our total displacement is simply equal to 12.5 meters. Okay? And it's lying along the positive and positive x. Okay, and this is how we solve for the total displacement.